Okay, this little clip is going to teach us about the inverses of a function, what we mean by the inverse of a function. It's an interesting thing, but when we write x to the minus 1 in maths, that actually is the same as 1 over x. It's the reciprocal. When we write 2 to the minus 1, that's the same as 1 over 2, or a half. When we write f to the minus 1, that is not 1 over f. What it is, it's the undo or the inverse of f. For example, what's the undoing of adding 5 to a number to get us back to where we were? Minusing 5. What's the undo of doubling a number? We would undo that by halving. What's the undoing of square rooting a number? Squaring. Let's have a look at this example over here. So for example, we've got a function here, it takes an input, doubles it and adds 3. The inverse function actually subtracts 3 and then halves the result. Now if we put in a number like 5 into this machine, we wind the handle, put in 5, 2 times 5 is 10, plus 3 is 13, out pops 13. If we pop 13 into the inverse function, 13 take away 3 is 10, divided by 2, once we wind the handle of course, out comes 5. The inverse function literally undoes what the function does. Another example that we'd be completely familiar with, sine of 30 on our calculator would give us a half. The undo sign, shift sign on our calculator of a half, will give us 30. In the next clip, I'll teach you how to find inverse functions. Okay, now that we've established what an inverse function is, let's work out how we go about finding the equation of an inverse function. Right, essentially what we do is we write down our function. I'm going to start with this one over here, it's possibly the easiest one. We write down our function in the form y equals 7x minus 3. Then what we do is we interchange x and y, so we write x's where there were y's and y's where there were x's. Right? And that's a fairly obvious thing to do. If you remember previously, what was an input into a function became an output. All right, so now the inverse takes the output and gives us back the input. I'll show you an example of that now. If we put 2 into x here, we get 7 lots of 2, 14 take away 3 is 11. All right, now what we want is we want the 11 to be our input to give us 2 as the output, and that's why we've swapped x and y around. What I now do is I rearrange this formula to get y on its own. So x plus 3 is 7y, right? Or 7y is x plus 3. So y is in fact x plus 3 divided by 7, right? Or f inverse of x is x plus 3 over 7. And I think we can quickly check that if we put 11 in as our input here, 11 plus 3 is 14 over 7 is 2. We've found the inverse. Right, let's do this one over here. Y equals 2 to the x plus 3. So x is 2 to the y plus 3. Now I need to get y on its own. I'm going to subtract so I'm going to subtract 3 from both sides. I get 2 to the y. Lastly, I'm going to write in the form y equals, and now I need logs here. Y will equal log base 2 of x minus 3, or f inverse of x will equal log base 2 of x minus 3. The last one, y equals 12 over x minus 2 plus 3. Just to save time, I'm going to write it straight down. X is 12 over y minus 2 plus 3. Subtract 3 from both sides. X minus 3 is 12 over y minus 2. Right, now I could multiply both sides by y minus 2, but in fact if I've got x minus 3 as 12 over y minus 2, then y minus 2 must be the same as 12 over x minus 3. I've literally just kind of rearranged where those things are in it. So lastly, I'm going to add 2 to both sides. So f inverse of x is in fact going to be 12 over x minus 3 plus g.